you so much for taking the time to speak to us today. So just to start us off, tell us about NAWA Technologies and what you do.
So NAWA Technologies is a French company, also with a footprint in the US. We are doing vertically aligned carbon nanotubes, and each and every word counts. It's nano scale, it's really small. It's carbon, it's black. It's actually the blackest material you can get. It looks really much like velvet, if you like, black velvet. And all those tubes are vertically aligned. They are so close to each other. There's 100 billion of those tubes in 1 square centimeter. It's really a dense material at nanoscale, right? And that is what the properties are coming from, and I'm sure we're going to talk about that. It's not something easy to produce, right? And so that's what we're doing, really.
And you've just been appointed the new CEO. I guess congratulations. And also,
Thank you.
No worries. What is your vision for the company? So you've had loads of automotive experience. So what's your vision for the growth of NAWA Technologies?
So the vision is to move from all the development phase that they've gone through in the past years and transition to the industrial phase and the scale up phase. So turning this technology, this extraordinary, really small nanoscale material into products, into industrial manufacturing customers, and large-scale business development. And so that's what we're currently doing.
And you mentioned a little bit earlier, but tell us a little bit more about NAWA's revolutionary 3D carbon-based nanomaterial. What makes it unique?
So this material, because of the density, because of the sun, and because of the carbon material, has really specific mechanical properties, electrical properties, conductive. It's like it's a material that has a very high density, and that plays a role in again electrical properties. You can heat the material up and get features like de-icing for airplanes. You can have composite material that have very specific mechanical properties. And then you can combine those properties. So you can have a composite material that you can heat up if you plug it. And that has a lot of attraction and interest for the market at the moment. So composite is going to be our first go-to-market application. The other property of being a structure that is fantastic for exchange of particles at molecular scale, that plays an important role in fuel cell technology. So that is also something we're going into. Two reasons for that. One is fuel cell uses platinum as a catalyst material, which is very expensive, and has an efficiency that goes down over time. And so the lifetime of a fuel cell is actually limited by the behavior of the platinum particles. That's a problem we solve with our material structure. We can deposit the platinum particle best on the nanotube structure, and then we can block them and prevent them from aggregating and getting the performance to go down. And so we increase the performance of fuel cells, and we dramatically extend the lifetime of fuel cells. So that's the second application. Third application will be on battery for EV cars and any other electric battery purpose. There, same story. You use the structure of the material together with the one or the other chemistry that is used in the battery environment. Can be lithium, can be silicium, can be something else. We'll figure it out. But the important point is the synergy between the structure of the material and the chemistry that is used in the battery. So ultimately, if you look at those three domains, right, it's not our material in itself. It's the combination of that material with something that already exists, right? So we combine nanotubes with existing carbon fiber products. we combine it with existing fuel cell products, or we combine it with existing or to come battery chemistry. And the value comes from the synergy between our material and those existing solutions already. And that's kind of fascinating if you think about it, right? It's a really thin changes, right? It's microns that we introduce, and that changes pretty much everything.
Yeah, no, it's brilliant. And it's very exciting as well. This is such a unique material market. It's a unique product. You mentioned a little bit there, but what in the big picture scale, what do you think the impact will be on the e-mobility sector? How do you think this will change how some people view the road to electrification?
Yeah. So also a fascinating question that's, in a sense, whether you look at composite material or you look at fuel cell or at battery, it all contributes to decarbonation solution. So composite, the impact of our material is you can use either a lighter material, because for the same resistance you can put less carbon fiber. What I didn't mention so far is, adding a layer of our carbon nanotubes adds almost zero mass, right? It's again, it's really thin and it's perfect structure. It's only 10% of our product is material. The rest is air, literally, right? So you add zero additional mass while you dramatically strengthen the material. And as a result, you can use less composite material and go for a lighter solution. And that's, of course, of interest in the car industry, in the airplane industry, and aerospace, of course. Hydrogen is the same, right? You can use less platinum material to get to the same power. And platinum is not only expensive, it's really difficult to produce and not clean at all, right? So the CO2 result of platinum production is not good. The less you use platinum, the better by far. And by increasing the lifetime of the fuel cell. Of course, if you use only one fuel cell over a lifetime instead of two, then yeah, you save 50%. So that's also a huge benefit. And on the battery side, I don't need to tell you the challenge of EV cars today, right? In terms of range, in terms of charging speed, in terms of overall infrastructure required to recharge all the EVs that we're going to get within the next 10 years. So there as well, if you have a lighter battery, more powerful, less material, is also fully in line with the decarbonation challenges we're facing at the moment.
Brilliant. And lastly, what can we expect to see from NAWA Technologies in the next 12 to 18 months?
So a lot is the answer, right? As I said at the beginning, we're transitioning from a little bit of a research and development activity to really industrial and scale up, right? So we're in a fundraising activity at the moment. We have the customer traction that is developing. We're going to launch new machines in the coming month, and we're going to build and move to a new plant towards the end of 2024. So that's exactly 18 months, right, more or less from now. So if we would talk again 18 months from now, right, I will probably be in a different office, and we would have new machines on the floor, on the plant floor, producing for new customers and shipping, right? So that gives you an idea of how much is going to happen within that period of time. Really exciting.
Oh, it sounds really exciting. Well, thank you so much for taking the time to speak to us, and good luck with everything.
Thank you very much. Thank you.